Hello everyone, and welcome back to our channel. Today, in this video, we'll explore the basic concept of a phase lock loop or PLL. Let's suppose we want to synthesize a frequency of 5.15 GHz for an X-band LNB. To generate 5.15 GHz, we need voltage-controlled oscillator, VCO. As the name suggests, the VCO's output frequency can be adjusted by applying a tuning voltage to its input. Here is the graph of frequency versus tuning voltage taken from datasheet of the VCO HMC430LP4. Remarkably, this VCO spans a frequency range from 5 to 5.5 GHz. Our target frequency of 5.15 GHz is achieved when the tuning voltage hovers around 3 volts. So, the question is, where does this tuning voltage come from? This tuning voltage is generated by the phase-locked loop, IC, and supplied this tuning voltage to the VCO via a loop filter, essentially a low-pass filter. Inside the PLL, there is a phase comparator and two counters, one divided by R, and the other divided by in, and a charge pump. The phase comparator plays a crucial role. It compares the phases of two RF signals. One signal is derived from a reference oscillator, which is divided by the R counter, and the other signal is generated by the VCO, divided by the in counter. To understand, just do the rough calculation. Let's suppose our reference oscillator is of 10 MHz and our phase comparator can compare phase differences up to a maximum of 1 MHz. So, the frequency of both RF signals needs to be around 1 MHz for effective comparison. To achieve this, we must set the values of R and in. In our case, to reach 1 MHz, we'll set R to 10 and N to 515. These values ensure that the signals are compatible for phase comparison. The purpose of charge pump is to modify the DC voltage applied to the VCO, causing its output frequency to adjust accordingly. This feedback loop ensures that the VCO maintains the desired 5.15 GHz frequency. To sum it up, a phase-locked loop, or PLL, is an essential component in synthesizing a stable local oscillator frequency. By using a phase comparator, counters, R, and a charge pump, it can maintain the desired frequency even in the presence of deviations. That's a wrap for today's video on the basic concept of phase-locked loops. If you found this information helpful, don't forget to give us a thumbs up, and be sure to subscribe for more exciting tech content. If you have any questions or topics you'd like us to cover in future videos, please leave them in the comments below. Thanks for watching,